Hey guys, welcome back to my channel. In this video, we'll be solving another resultant of force system problem, which is part of the FE exam review session that I just started. This is a simple practical application of the concurrent force. The question reads as follows. The ocean is holding a wind turbine blade with a mass of 10 tons metric. The tension in Newton in the right cable is most nearly 34,200, 24,250, option C 49,500, and option D 98,100. So the very first step on this one will be to draw the free body diagram to make it simpler. So we have T1 for the tension of the cable on the left, and we have T2 for tension of the cable on the right, and then we have our blade pointing down. The next step will be to probably calculate on the side the reaction force of the wind turbine blade. So we're given a mass of 10 ton. We'll have to calculate the weight in order to be able to find the tension on the cable. So if you're not familiar with the conversion from ton to kilogram, you can pull up the FE reference handbook and search for conversion, and you'll find in the table that in order to convert from ton to kilogram, you'll have to multiply whatever you're given by 1,000. So we're given 10 tons here. So to convert that to kilogram, that'll give us 10,000. Now, in order for us to calculate the weight, we'll use the equation mass times gravity, which will be equal to 10,000 kilogram times 9.81 meter per second squared, and that'll give us 98,100 Newton. So we know that we'll have 98,100 Newton here. So we have 60 degrees here, and recall that in a triangle the summation of all the angles should be equal to 180 degrees. So since we're given the 60 degrees here, we know that this is a 90-degree angle. So in a perfect world, 180 minus 90 minus 60, that'll give us 30 degrees. So we know that this angle will be 30 degrees. And likewise, this will also be 30 degrees. So right off the bat, we can see that the way the blade is held is in a symmetrical system, meaning that the tension on cable 1 will be equal to the tension on cable 2. So with that in mind, we're gonna write our static equilibrium equation. In order for this system to be in equilibrium, we know that forces in the x and y direction will have to be equal to 0. But on this particular example, we won't have to worry about the x component, since the weight that needs to be supported is only acting in the y direction. So with that in mind, we will write all our forces that are acting in the y direction. So for tension on the cable, since those are facing the positive y axis, that will be the y component here of that tension. So that will be t sine 30 degree. Since ty is the opposite of the 30-degree angle. So we also could have used cosine, but it would have been the cosine of 60 degrees since PY is the adjacent side of the 60-degree angle. So either way will work. So let's write it down. So we will have Ty is equal to T sine 30 degree. And since we know that this is a symmetrical system, we could technically just write 2t sine 30 degrees. So, during the FE exam, your time is very limited, so you don't want to spend time writing out every single thing. But, just for illustration purposes here, I'm going to write down both TYs, if you will. However, for an exam like the FE exam where time is of essence, you want to make sure that as you're solving the problem, you skip things that's quote unquote make sense. So we'll have T sine 30 degrees plus T sine 30 degrees. So that's this Ty here. And then minus 98,100 should be equal to 0. We're gonna solve for T. So this will be equal to 2t sine 30 degrees. We just add this up is equal to 98,100. And then we'll have 2t times sine of 30 degrees in what is 1/2 is equal to 98,100. And we can divide 2 by 2 here. This simplifies. So T will be equal to 98,100 Newton. And looking back at our proposed answers, there will be answer D. Please don't hesitate to comment any question that you have or subscribe for more problem, or please let me know if you'd like me to review any specific concept. We'll see you on the next one. Thank you.